you're a practitioner, you now, in some sense, if you want to think about it, have a list of techniques you can use. Any reasonable person then would say, okay, well, which one should I use? As a practitioner, you can't try everything, right? But hopefully what this will do is shorten that path to allow you to quickly try more things than just one. So you're not just relying on your one technique over and over, and maybe build an intuition on like what types of problems, what types of data, like which technique would you try first, given what you're working on?
We had all of these discussions with customers about like, what is explainable AI? How does it work? There's a lot of questions when it comes to like, what is it different from interpretability? Sort of what does it mean when I get back these results from explainable AI? And we kind of built up this general knowledge of how to best use explainable AI and how to interpret it and sort of best patterns and practices.
Hello everyone, welcome to another month of our book club chat. This month our book club is reading the book Explainable AI for Practitioners, and we're super grateful to have the book authors Michael Munn and David Pitman with us today. Welcome Michael and Dave. For anyone joining us today, please feel free to ask questions directly in the Zoom or ask in the chat. Okay, let's get started with a round of introductions. And feel free to type your introduction in the chat if you don't feel comfortable to chat with us, or if your microphone doesn't work. Yeah, totally fine if you just type your chat online. Yeah, so I'll get started. My name is Sophia Yang. I'm a data scientist at Anaconda, and I organize this book club to read data science and machine learning books. We read one book a month, and we chat with the authors, hopefully by the end of the month, if they are available. Michael and Dave, would you like to introduce yourself?
Sure. I'll go first quickly. Hi, everybody. My name is Michael Munn. I'm a research software engineer at Google. My work is sort of, my background's in mathematics. And so my research work is kind of focused in more like the mathematical foundation, like understanding of machine learning and AI. And yeah, thanks again for having us here, Sophia. It's great to see you again. Thanks everybody for joining. And yeah, this book is coming out of a project that Dave and I were working on. Like just last year, a couple of years ago, we got started with this. So yeah, it's been a fun time.
And hey everyone, thanks for joining us. I'm Dave Pitman. I lead a few different teams in Google Cloud on our LML platform, one of which is our Explainable AI team. I'm a staff software engineer, and previously was a research scientist at MIT. Background is in AI and human-computer interaction.
Wow, impressive. Thank you so much. Thank you so much, Dave, for joining us today. It's the first time. So happy to meet you. And Michael, it's the first time we see you. It's amazing. We loved your previous book, and I love this book even more. It's amazing.
Great. That's good to hear. Good.
So, yeah, anyone else wants to introduce yourself? No pressure if you don't feel comfortable. But if you are, that'd be great. Okay. Okay, cool. Cool.
Yeah.
Thank you.
Okay, awesome. Meet you. Is it okay? You're Sathvi. Okay, nice to meet you.
Awesome. Feel free to type your questions in the chat as well. I guess I will get started with a question. What's the story of the book? I want to know more. Like, how many years have you been thinking about this book? How long have you been writing this book? What's the story? How does it get started?
Maybe I'll give my I'll start it off, because I think it sort of like happened very naturally, that like it was an idea I had, and then I realized I wouldn't get very far without people like Dave helping me out. So then I looped in Dave, and maybe then Dave can tell his story of it. But yeah, I guess it was sort of came after we had worked on that ML design patterns book, which I was just like a fun experience, and was looking to like, write something else. And I had personally just gotten really interested in explainability. Like it's just I don't know, it's an important area of ML, and for me it was more like just like a pet project. I just wanted to know more about it, and like what better way to learn something better than to like teach it, and if I'm not going to teach it, then like write a book about it. So part of it, to be honest, was like a chance just to learn more about the field and really do a deep dive, and then just like collect my thoughts, because it felt like just like a good time for it. Like there was like a lot of good resources out there, but as I was trying to get into it as a practitioner and like understanding what explainability was all about, I just felt like there wasn't a good, there's a lot of really good resources, but I just wanted something that sort of, sort of bridged that gap between, I don't know, the research articles I was reading and then like the implementations I was seeing. So then, yeah, and so then just sort of sat down and thought like, what would a good book entail, and drafted up like a general outline. And then, like I said, like this kind of thing I would even want to do alone, and I certainly wouldn't consider myself an expert at the time, like maybe now about like in explainability. So I was like looking out internally in Google, like who do we have? And like one great thing about working at Google is there's such really great people here doing really great, interesting, cool things. And then I think, yeah, Dave, even though I was in cloud before, we had never really interacted, like we just never had a chance to. So then I got pointed into Dave, and that sort of like was the beginning of the collaboration.
Wow.
Yeah, I mean, I think on our end, so I've been working on Explainable AI for many years now, and it was really like fortunate timing when Mike reached out, because we had all of these discussions with customers about like, what is Explainable AI? How does it work? There's a lot of questions when it comes to like, what is it different from interpretability? Sort of what does it mean when I get back these results from Explainable AI? And we kind of built up this general knowledge of how to best use Explainable AI and how to interpret it, and sort of best patterns and practices. But we didn't have like a great way to get it out to people. Sure, we could put documentation on Google Cloud's website, but I think, even for me, there's always a question of like, okay, is that a best practice, or are you asking like more in the context of how to use like a particular like library or platform's tools? So this was really great to step back and be able to provide more of a comprehensive view of an explainability, and how people can just like pick it up and start working with it.
Yeah, I love it so much. I love you have like both the theory part and the practical part, which is the code, and the code just runs very smoothly. I really appreciate the coding part of the book. And I was like super excited to read this book. Like last time when Michael mentioned you were working on this book, I was like, oh my God, I really want to read it, because there is not a very good resource to learn about explainable AI right now. I feel like there's not many books, not many courses. It's just like barely any. So
that's funny. I mean,
yeah.
I'd seen you had an article actually, Sophia. You pointed me to like a Medium article you had written about like explainability and interpretability, and that's kind of how I felt too. It's just like if ever you want to like learn like I don't know, a technique, or learn how something worked or how to implement it, you'd find like a lot of maybe some blog posts. I mean, yours is really well written. It has like covers a lot of different techniques, which is really cool.
Thank you.
And it's like, you find these blog posts, and then it's like sometimes, they're contradictory, they're a little bit confusing, or like not so well written or something. Not yours, obviously, but like some of them are. And then like, I mean, yours is great. And then you like, there's always like all this like research that's being done. Like it's a very active field of research. And so it sort of felt like there's a gap in the literature, right? As you would say, like, there could be a useful spot for it. And it's funny too, like that in writing the design patterns book, if you remember the very last chapter, this ties in with like Dave said too, with like, the customer aspect from cloud. The very last chapter of the design pattern book is like the business stakeholders. We talk about like, things like explainability and then model fairness and stuff like that. And I think when we were writing that chapter, it just felt like, it was like, there's a lot more you can say here. And at first I was like, let's write a book about like explainability and fairness and like everything. But then that just became really too big too quickly. And it was like, actually just doing explainability well will be really useful. So it kind of like honed in really quickly. But at the end of the day, it was all like with the idea that Dave said of like having, like customers or like, the business stakeholders in mind. So it's really valuable for that.
Yeah, exactly. Speaking of blog posts, when I wrote my blog post last year, I was having such a hard time finding consistent resources. There's like this research over here doing this one thing, particular thing, and this professor is talking about this. And then another professor is talking about another approach. Like there's not a place where they compare different approaches or like tell us what's the best practice, what tools to choose. And I like you guys just combine everything together, really great, and give us pros and cons for each method. It's just like so great. I love it.
Yeah, I was really happy we were able to get the pros and cons list in there. I don't remember how it started. Maybe we were just sort of like debating how to order the techniques within the books, but then our editor, who was fantastic to work with at O'Reilly, kind of looked at it and said like, oh, nobody's ever done this before. And we were like, okay, so we had a bit of back and forth about getting that formatted and understanding in a way that was like really presentable. But I felt like distilling it down to something where, like you were saying, you can quickly sort of look at different techniques and be like, hey, is this going to fit what I need? Is this really like what's going to be best for my situation? Or am I sort of going down the wrong path here and I should try something else? Was really important to us.
Yes, I love it. Michael, you mentioned fairness. That's my question. Next question. Like explainability and fairness seems go hand by hand. So like, what's your perspective on the two topics? If I want to learn more about fairness, like where should I start? And is explainability, your book already cover a lot of the fairness already?
I would, from my perspective, I feel like they're, part of the reason that the book became about explainability and not more broadly about like explainability and fairness and maybe even like ethics and things like that. I mean, because originally that was sort of the idea that I, in thinking about an outline for the book, I was like fleshing out like, topics, what to cover and how much you could make it, so again, like with the idea of like focus on a practitioner, like implementation. Going back to the pros and cons thing actually was Dave's idea. It was a really good, we had been like writing, and I think like in that context, it really helped because in writing the chapters, like I oftentimes will get like too bogged down in the technical aspects. And it's like, but we wanted it to be for practitioners, like what's the useful for these tools. And so we had this, so Dave had the idea of like putting in a pros and cons, like high level, like for each of the techniques. So it worked out really well. But I think like with the fairness, I think the techniques were different. It's a different enough field. Like the approaches are quite different. The methodologies are different. And it felt like it would be like, honestly, I feel like you could write, I mean, it's sort of an evolving field also, but I feel like that would sort of deserve its own book, its own like treatment. Like trying to squeeze it into a book with explainability would just not be able to go deep enough into any one of the two. So I also think like fairness is really interesting and important, and it's like a pet interest. Like whenever I see stuff coming out, I try to keep up the literature, and it's also a really quickly evolving field. But the again, like the goal almost and like the approach, they're different enough that feels that it would deserve its own treatment entirely.
Yeah, I think all of this falls under the umbrella of responsible AI and fairness. Explainability really helps you understand how the model is behaving or how the data has influenced the model. But fairness is really about, I think, ultimately understanding how you can change the model to have more equal outcomes, or at least understand if it has unequal outcomes. And so it's both like a more targeted set of questions you're asking, as well as a set of like remediations and actions that go hand in hand with those. So like Mike said, it's just different enough. And I think the field also is one that's like a few steps more nascent than explainable AI is. And so, like I'd love to write a similar book for fairness in another like year or two, once I feel like there's been more research, we've had more sort of real world use cases where we can look into how fairness has been applied across a bunch of different realms. I'll personally just say, like, I'm almost continually disappointed when I read fairness literature, and it always comes back to the same 3 case studies. Which just says to me, that's not a knock on anybody who's doing the fairness work. I think, it's very good work. It just means that we're still very early on. Like if you look at explainability, it was in the exact same place 5 years ago where everybody was like doing explainability on images and being like, here's an image of a cat and here's an image of a dog, and you can see why the cat's ears influence the model's predictions instead of the dog's nose or something along those lines.
Yeah, that makes sense. I'm looking forward to your fairness book if it happens next year. Okay, I have several other questions. I really like the chapter on where you talk about using explainable AI to detect model drift, right? The traditional drifting method is like only work for univariate distributions, but explainable AI techniques works for all kinds of distributions, even if it's not univariate. So, but like, do people actually do that? Because even like GCP, I think, uses looking at the traditional methods for model drift. It's not using XAI, like, or
it does.
It does? Okay.
Yeah,
sorry.
yeah. No. It's good to hear that. It means we probably need to make that more evident. But yeah, people do. It's been used quite successfully actually across Google. And there's one blog post that goes into some nice details of it, and then I know of a bunch of other instances where it's used. That I can't dive into a bunch of details. But it's super cool. I think it's a great application because it, if you think about like when you're monitoring a model, like unless you're doing something like continuous retraining, we assume that the model, is literally fit to the set of training data that it saw when it was trained. And that means that if it starts encountering scenarios outside of its realm of training data, sort of that scope, it may not behave as you had expected. And so doing something like just looking at distributions, I think can capture like really wide out of band predictions, or stuff just sort of outright failing. But if you sort of step back and say like, hey, what we're actually interested in is the model starting to behave differently in prediction while we're monitoring it, meaning we either need to like retrain it, or maybe like something failed with our like feature engineering or something. That's getting much more to sort of the heart of the question you're asking with model monitoring, is to understand, is that model behaving sort of in the real world, in practice, as you saw it behave when you were training it and then testing it?
Right. I see that like super useful because it provides insights on what to do next, your actionable items, more so than the traditional methods. Okay, so it's great to hear that Google already implements it in Google Cloud, but for the rest of us, some people who don't use it, it could be like computational, expensive. The system to monitor XAI method like continuously could be really hard to set up. Like, how do you advise people to do that?
Yeah, I mean, I think probably the first question here is just one of scaling and computation costs, like you said, and so it might be easiest to just go with a cloud provider and scale that up. Another route that people take is you actually siphon off a random percentage of your live traffic and perform the more in-depth analysis and explainability on that. So you're not performing explainability across your entire prediction workload, but instead saying like, all right, I'm going to budget it to some amount. I don't know that there's like a magic number, like Mike, correct me if I'm wrong, but I haven't seen any like research that sort of talks about like, oh, what percentage of your prediction could you sample to be assured that you're getting a reasonable like understanding of your model's behavior. Probably like anything else, it depends on when you're getting edge cases or other things, and is your sampling truly covering that? But that's usually the most common technique to sort of work around this problem with them being computationally expensive, is you just sample some of your traffic rather than doing it for all of it. Or you can choose, you can do it, there's other routes you can go. You can do the route of doing something where it's like, it's a more coarse-grained explainability technique, and then if something looks off, you can start automatically performing either more sophisticated techniques that are probably more computationally expensive. You can also save some amount of your traffic to then go back and replay the explainability on it to investigate further. And in some cases, I think if you do need like an understanding at very low cost across all of your live prediction traffic, that's where you might say like, okay, a model that's been designed to explain its behavior as part of making a prediction is the way to go, which would be more of sort of an interpretable model. I think we talked about this at the beginning of the book, like there isn't like a hard line dividing interpretability and explainability. It's more of like a spectrum from one end to the other. And it's not that one is inherently better than the other, it's just sort of more what's suited to your use case.
Right, exactly. I feel like the model monitoring part is like so insightful when I was reading it. It's just like mind-blowing. wow, this could be used for model monitoring, but like it totally makes sense. Why didn't I think about it? Yeah, Michael, do you have anything to add on?
I would just say, like, I'm glad you brought that up, because it sort of like plays into the main, what I feel like is the main like thesis of the book too, which is that like these explainability techniques are really, best viewed as like a tool set. Like you have a new toolkit to use to better understand your model. Like I feel like when I first approached even myself, I sort of thought about explainability as like a collection of just like techniques, and like, here's this for that, here's this for that. And like, maybe like after you've built your model, okay, cool. Like it'd be really nice to be able to explain, to add explanations onto the model. Or maybe it's like, okay, well, maybe if my manager asks, like I'll be able to say, you need to be able to say like why, like maybe give some indication to be able to explain model predictions. But it's kind of like a nice to have. But then, but at the end of the day, it's and we sort of say this, and I hope it comes across in the book, is that like these techniques are less of that and more of like a toolkit. Like now you have a lot of tools, and they're all useful to better understand your model. And that means they're useful as tools to better understand your model when you're developing it, when you're deploying it, like once it's deployed. And this is just one example of just like how these tools are useful for, post deployment, like for model monitoring. So I'm glad you brought that up. So it's kind of like sort of like plays into the main point of the book in my mind.
Awesome. Yay. I'm glad I noticed it.
Yeah.
There was a section talking about like it is important to do sanity checks for those methods. And it seems like you need to have explainable AI methods to explain explainable AI methods. It's like a loop. That part was interesting to me, and it sounds very complicated. I feel like as practitioners like us, I don't really like check each method, really. I just use it. And a follow-up question is, you mentioned in the book there are some models that failing basic sanity checks, like the guided backprop, guided Grad-CAM. If they're failing basic sanity checks, should we still use them? What's the value in them?
Yeah, that's a good question. I know Dave's a lot to say about Grad-CAM, so I'll let him.
Well, it's not just that actually, but yeah. Go ahead first, and then we'll.
I was just gonna say, like, yeah, like, we talked before, and Dave mentioned how, like, fairness seems like in a very like nascent stage, and explainability is a little bit more, perhaps maybe a little bit more evolved. But that being said, too, I feel like explainability also is there's still a lot to be work to be done in explainability. And so I sort of felt myself when writing the book that, we're presenting a lot of techniques, but at the end of the day, and we're trying to say, like, if you're, and the goal really is like for this technique, like you make a lot of choices as a practitioner. Again, like here are the pros and cons, and as you're making a choice for that hyperparameter, here's what you want to have in mind. Like here's what you want to be aware of, and that was the goal for how we approach the different techniques in the book. But then at the end of the day, there's still like a lot that's not known. It's very much an evolving field, and there's like a very active area of research. And so that part about the sanity checks, I think, sort of came down to, okay, like you're a practitioner, you now, in some sense, if you want to think about it, have a list of techniques you can use. Any reasonable person then would say, okay, well, which one should I use? And I hope the takeaway was there is no one answer, right? There is no use this technique. And I know we had examples in the book that, our editor at one point was like, you present this technique, then you show this one example and it does worse than another example. Are you sure you want to show that in the picture? And I was like, actually we do, right? Because what you want to say is like, it's not like you're like, here's a technique and here's the better one than that, and here's the better one than that. And you'll just skip into the chapter and do that one technique. It's not like that. It's like a collection. And so with that in mind, I think, like, as a practitioner, you can't try everything, right? But hopefully what this will do is shorten that path to allow you to quickly try more things than just one. So you're not just relying on your one technique over and over, and maybe build an intuition on like what types of problems, what types of data, like which technique would you try first, given what you're working on? And yeah, like some techniques may have caveats. They may have big caveats, but that doesn't mean it might not be useful for your use case. And again, like to be aware of it. And personally, I guess just from my perspective in exposition, I kind of like to see a progression of ideas. Like I like to see like how things build to get to a certain place. And that doesn't imply that they're, always improving. Again, like it's very use case dependent. It's very data dependent. And like There's a lot of other factors that come into play when you're making these decisions. But including other techniques, I think we even went back and forth on if we should remove certain sections. Like want to make sure we're not putting too much emphasis on techniques that may be more problematic than others. But again, I think we sort of landed on, it's also good to be aware of the flaws. Like it's good for anything. It's good to be aware of what's good and what's bad. And it gives you a more rounded picture of the field and where things are. But I mean, that being said, we couldn't include every single possible technique too. So some had to be left out. But I'm curious what Dave has to say in regards to that.
Yeah, I mean, I think that with these techniques, like there's some techniques we see repeatedly come up. And like Mike was saying, they're not necessarily all bad in and of themselves. It's just they've probably been supplanted by better techniques, better understanding of how explainability works, how it can be used. And so these are like more outdated. But by virtue of having been around longer, you're just going to find more content on the internet about them. And so I think it appears like all these techniques are like really popular when it's just like, they've like had more time to have, more posts written about them. And so on and so forth. I think that the issue here, and this is what Mike was touching upon, of where I think it was better that we included some of these techniques, even if we don't think that they're necessarily that useful in a lot of cases, is that if you just see like the technique isn't included, or we just had, I don't know, like a blank page for the technique and like a big like X over it, probably would not be that useful, because you're like, well, wait a second, like either I've seen these like techniques all over the internet, like why are these guys not including it? Like, do they even know what they're doing? Or they're just telling me not to use it. Like, what's up with that? Like, why can't I use it? It seems like there's been tons of use of it. And it's not really until you dive a bit into the technique and begin to understand, oh, this is what's happening. This is why it's probably not that useful. Is it important? And this is one thing I've seen a lot with people working with explainability, is that, these techniques are not like a magic, they're not magic. They're not going to like tell you perfectly what the behavior of the model is. They're going to try to essentially provide an understanding of what the behavior of the model is. In some cases, that approximation turns out to not be that useful. And like a great example of this is a technique that we dive into the book called LIME, which stands for Locally Interpretable Model Explanations, if I remember correctly. And LIME is very popular, one of the first techniques that came out. It's a really clever idea, actually. It says essentially, it works across a bunch of different types of models. But the easiest way to explain it is with images, and to say like, okay, if I'm gonna like take an image, what if I just start removing parts of the image and seeing if the model's prediction changes as if I remove parts? And if it changes a lot, then it probably means that part was influential. And this sounds like a very good idea. And then you can get this very nice sort of like coloring over the image of like, oh yeah, this section of the image was like very influential in the prediction or not. And that was great. And it got published, and it's like, oh, this is really good. But then what people came to realize was like, oh, wait, we haven't really frozen what the model did, because when we remove those sections, we don't sort of just like, squish the next two sections together, like the missing parts of that missing part of the image. We don't sort of like vacuum it out and suddenly the parts next to it are like squished next to each other. What will happen is, in fact, the model may start turning its attention. It's kind of almost like grasping at straws. It's like, okay, well, maybe it was really influential on that part, but maybe now something else appears to be really influential in changing the prediction, because with that lack of information, it's sort of fallen back to other parts of the model to use that. And so you're not necessarily getting information about how the model made the prediction on the original image. It turns out it could be a really poor proxy for it, because the model sort of turns its behavior or influence or attention elsewhere on the image. Whereas with that original image that had all the sort of complete picture, maybe it didn't pay as much attention to it. It's sort of like if I covered up one eye, and it's like, okay, well, now I'm telling you all about the stuff I'm seeing out of one side of my eye, but only because I have this eye covered. It's, just because I can't see stuff out the other side of my eye. And once you understand that, and you understand sort of those limitations, it's like, okay, now I begin to see where this is a technique that may not work for what I need to do. Or it may be when I need to go explain to stakeholders, like, hey, this LIME system that like predicted what we have, like, yeah, here's how we need to view this. It's not just about it's magically sort of like telling us which pixels are the most important.
So does it mean we shouldn't be using limes?
I think that for the most part, lime has been supplanted by other techniques that are more generally useful. One that we've seen a lot of success with is techniques based on either integrated gradients or based on the concept of integrated gradients, because that continually sort of equally uses all the information in an image. But there's also places where for like text, lime, I think still can perform very well. And a good example I can think of just at the top of my head where lime may be really useful for you is like, let's say I had a like quality control computer vision system, and it's looking at like just the same image of some, you know, widgets on a factory line day in and day out, and you're wondering like, hey, are the margins of this image like useful? What happens if we remove them? And lime might be really useful for that, because you could see like, oh, you know what, like we rarely pay attention to the like edges of this image. We could probably like downscale our image, like crop it even more to like make a faster model or something. And we don't have to pay, there's not much influence around the edges or something along those lines. So this is where we get back to like, there's a lot of trade-offs. There's a lot of pros and cons, you know, there's not one single right answer. I think it's just like if you were asking somebody to explain, you know, why they like a movie or a particular like food or something, there's not going to be one single universal way everybody's going to describe how they like movies and rate movies.
But then also back to it, it's like knowing, but also like presenting it and like showing the technique and understanding like how it works under the hood, like what's really going on, will allow you as a practitioner to make an informed decision. Like that, like the example Dave just gave is really great. It's like, well, maybe like in this case, you like lime, you know, any caveats that it has are actually not that bad in that setting. So I think it's really important still to know that, like, you know, what's really going on with these techniques to make the right choice. And again, like there's just not going to be, if there was like a one fix all, like just use this technique, then it would be a very, very short book.
Yeah, we just make it 3 pages. Like, you got an image model do this, you got a text model do that. But not the case, unfortunately.
Right, it's complicated. So Michael mentioned, Dave, you might have opinions about Grad-CAM. I'm curious if you're willing to share.
Yeah, I mean, I think the section we wrote there, Grad-CAM is a technique that looked interesting, and it turns out to just not in practice result in good explanations. And this has been sort of shown in the literature. There's I think some flaws that are in the sort of original Grad-CAM design. That means that unfortunately it's not that accurate of a technique. And there's been work to improve it. Grad-CAM++ actually overcomes many of these limitations. But the core of it, my advice would be largely to probably look at alternatives from Grad-CAM. I think it is, yeah, it's just the approach it takes, where it's kind of trying to work specifically on CNNs and look at the gradients and how the classes are activated. Interesting idea, like the paper itself originally showed some like good promise, but then in practice what we've seen is it can be a bit erratic.
Michael, Mike, do you have anything to add?
I would just say too, like, you know, back to the idea of like, you know, what techniques to include and how they were treated. Like, you know, so what we try to do, for example, for that is like to address it, treat it, and going back to what Dave said too, you know, part of the value also is you'll see these techniques, like you'll see these on the internet, you'll see people write about these techniques, for example, but then also like you'll still see in research papers, people will have those techniques as a comparison against whatever their new technique they're suggesting is. And while the book is not meant to be a ramp to get you ready for like, you know, research and explainability and like, you know, your next step is now to go start reading research papers, I do think there is some value in like getting the value is like to get you up to speed very quickly in the field and to be aware of it. So if you did pick up a paper, it wouldn't feel so foreign. Like if you did feel comfortable enough to like, you know, hopefully it's really focused on practitioners, and hopefully if you're a practitioner, you feel enabled and empowered to be like, okay, here's an idea. I understand generally how it works, big picture. I understand the choices I have to make when implementing this. I even have some code that maybe I can look to, and there's some really great libraries out there that we were using for the code. So that's not us. That's like these libraries that already exist, which are really great. You can see like how these things work, and you can really jump into it and get your hands dirty with implementing these ideas. But then maybe if you do come across a paper, or like you see something and it's, you're reading through and it's like, okay, here's our new technique, and we compare it against all these others, you'll have a place to be like, okay, like I know what these things are, I know what they mean, I've seen them, I have a place I can reference. So by no means is the book like a reference for all explainability techniques. There's just no way that'd be a much bigger book also, and a sort of very much out of scope. But it does give you an idea of like the state of the field and like where things are, what's good and what's bad, and just something to be aware of as you're continuing your journey and like learning about explainability or using explainability.
Right. I mean, speaking of libraries, I think one reason Lime is so popular because the package Lime is ready to use, so easy, like compared to the concept driven method like TCAV. It's just like there's not an easy way to implement that. It's kind of complicated, and also like model distillation is just kind of, you have to make things your own. There's not an open source library out there for us to use. So, and for like data scientists who have other work to do, we just want to use this tool to get the results ready. So what do you think of that? Like the availability of open source libraries versus maybe a better method, but more work.
Yeah.
And it's not well educated. Yeah.
Yeah. I mean, I think this is where, like things like Lime and SHAP, they've had the virtue of being around for several years. And so they've gone through several iterations of improvement,
Right.
and pretty predictable path for explainability techniques is like they start out nearly focused in just one model modality. Then it gets expanded. Okay, does this work for other modalities? And then you have this sort of like clunky library that probably like esoterically hooks into your model, like just framework, and maybe it only supports PyTorch, maybe it only supports TensorFlow or something. And then over time it gets expanded from there. That's why we see something like you were saying, Lime, it's so easy to use because it's had several generations basically to improve upon it. I mean, like you look at the most popular Lime library and the initial commit is 7 years ago. And SHAP, like they've been heavily iterating and improving on that. I think that the open source in general has a lot of benefits in terms of exactly that. You can have a lot of people working on a library, improving it, testing it out, contributing to it. What I've found with open source is where it becomes difficult is knowing where to use one open source library or different techniques within the open source library. Like I think actually, SHAP the SHAP library does a nice job of walking through the different alternatives and what you can do with SHAP. I think Captain, which is an explainability library for PyTorch, does a great job of saying like, hey, they have more of the kitchen sink approach. It's like, here's everything, but also if you need to dive deeper, like here's like the technique, here's the sort of one-line explanation of it, the formula, here's the paper if you need to go look at the implementation much more deeply. The real challenge that I see with these now is using techniques that once you get beyond this first wave of the library just working, understanding if the technique or the library will support comparing between models stably, and then even comparing between different model architectures stably. That's not necessarily the case. And I think a good example of this in the SHAP library is that they have built they have several different versions in SHAP of using Shapley values, popular way of working with structured data or tabular data to understand the influence of features. And they have, I think, 5 or 6 different techniques in there that you can use. There's kernel SHAP, there's fast SHAP, deep SHAP, et cetera, et cetera. They also have tree SHAP, and tree SHAP only works for tree-based models like XGBoost. And conversely, the other types of implementations for Shapley values do not work with tree-based models, except for their most generic kernel SHAP, I believe. And so you look at this and you're like, okay, great, I'm going to go with TreeShap because I have a tree-based model. Well, the way TreeShap works is it's based off of research that is specifically tuning using Shapley values and approximating them for tree-based models. So if you were to take your XGBoost model, probably like your baseline model as a data scientist, and you run TreeShap on it and you get back like, here are the most influential features. And then you say, great, now I have my DNN like, alternative that I want to try out and see if it's better, but I want to have some assurances paying attention to the same features we think are important. You can't necessarily compare those. It's sort of more of a like apples to oranges. Yes, they're both spherical fruits, but they're going to be different flavors of what's going on, because using something like kernel Shap or deep Shap has a very different way of computing those Shapley values. And so it's not a stable comparison to say like, oh, I know that because this is numerically important in my XGBoost model through TreeShap, that I can also be assured that it is numerically equivalent and important to my deep Shap explainability with my like PyTorch model. And back to your question earlier, Sophia, about like, oh, model monitoring, this is super cool. It's like, okay, well, so I compared two models and maybe things are slightly different. Why does it matter? Well, if you sort of go downstream and like what Mike wrote really well about in the last chapter around sort of like explainability through the whole life cycle, it's like, okay, we had these original explainability parameters or like values. And now we want to like, our DNN model has looked pretty good. So now we're going to introduce it into our like serving traffic in production. And, maybe we'll sort of keep both models side by side as we're ramping things up to see like, does the new improved model behave the same as the old one? You're not going to be able to use the same model monitoring and compare between the two and sort of say like, yeah, this model that we were previously doing model monitoring with explainability turned on, a more sophisticated way of sort of knowing that the model is behaving predictably. It's not going to work necessarily with your new DNN model that you've used a different sort of implementation of an explainability technique with. And so that's where I think like it becomes difficult to use an open source without really diving into the nuts and bolts of it. I think that there's been some work to provide more unified like approaches. Like I know that within Explainable AI at Google Cloud, this is like one of the prime things that we worked on for many years actually, was to develop Shapley values that worked across all different types of models. And so you could sort of reliably take it and use it in one place or use it in another. I mean, fundamentally, we could have somebody compare explainability values from like YouTube or Google Ads to explainability values computed in Google Cloud, and we would know that they're the same. They're like equivalent, basically. Like the architecture, everything that's used to generate it is equivalent, and we can be very confident in those comparisons.
Wow, that's a very good point. Yeah, there are not just choosing the method, but also choosing the method within the method. It's really hard. You have to like read all the documentations and still can't figure out what's going on, I guess.
Yeah, and nobody has time for that except for Mike and I. Spend a lot of time diving into this stuff. So, it's I think it really is like, this is one of those things where, and this is why, getting back to what Mike said about writing the book, like we kind of wanted to, I mean, this is classical, but we wanted to write a book that we wish we had at the beginning of learning about explainability, where it was like, hey, I don't have the time to go in and read, 20, 30 different research papers. I mean, I think I even just alone for chapter 7, where we're talking about sort of like how to interact with explainability, I like read like 30 different research papers on that, in addition to all the other ones that we looked at throughout the book. And it's like, people shouldn't have to, you shouldn't have to think like, great, I want to use this set of tools to improve how I'm using AI or ML. Like, let me go perform a lot of like lit review in principle before it. Maybe that makes sense when you're looking at like the core of your models, evaluating different model architectures, but explainability should make your life easier. It shouldn't be like a whole new massive project you have to undertake to add it to your toolkit.
Exactly. Well, thank you for all your work. I have a final question. Sorry, I have some more questions. What's your favorite method and why?
Well, that's a good question. I think for me, my favorite method. Well, it's like I think I don't know. I remember when I was like doing the research for this and like learning about different methods. When I came across the like TCAV, I just really thought it was cool. I don't know. I just thought it was really neat to be able to like look at the inside and like use this idea of like these directional derivatives, looking at the internal workings of the model, and in like some statistically significant way. Like I thought it was like a nice paper. I thought it was really nicely written. That always really helps when you're doing a lit review too. Like to come across as you're reading lots of papers, when you come across one that's like really nicely written, it's a really like nice idea. I don't know, maybe just like for sentimental reasons, I sort of like that. I like that technique.
Yeah, it's funny you should say that. I I also and what immediately came to mind for me was TCAS, which is concept activation vectors, and way to test them. I think there were a number of people who worked on this at Google. I have a lot of respect for all of them, and I know they're very accomplished like researchers. So I'm feel very good about like the work that they did, just sort of having interacted and worked with them. I think Bean Kim, the lead author, did a great job of like with this paper. And also like to me, like hitting at the heart of what you actually want to get out of a DNN model, which is you may not necessarily care exactly numerically, like is one feature, 1% more influential than another feature. If you can understand sort of, hey, here's some of the internal representations that have sort of self-organized in the model internally, and that we can look at those and understand like these representations are more important than other representations the model has learned. That is really cool. And it's one thing about explainability that's difficult is because of the way it works. You're often looking at how the data influence the model. You're not looking at how different parts of the model architecture itself influenced predictions. And TCAV, I think, is like the first real like solid breakthrough, I would say, in that area. There's been other work beforehand, which is really cool. I mean, there was, I think 2 or 3 years ago, or no, geez, not even with the pandemic, like 4 or 5 years ago, there was some really cool work done sort of showing like the internal visualizations of how CNNs were working. And that was really neat to look at, but it was also very, very difficult, at least for me, to understand how to take action off of it. I think TCABs now represents this refinement of like, okay, we're sort of distilling back down the behaviors of the model into these concepts that it's learned and what it's employed as it's been making a prediction.
Totally. I think that's pretty cool too, looking at the stripes, the dots, and there is actual data sets on that, make it easier, which is even better. Sorry, I guess that was not the last question. We got a question from the chat. Would love to know your thoughts about explainability on large language models, considering they're not trained on specific task data and in general. Do you think we will see in a more research on methods specific to explain these models?
Yeah.
I'm curious, Dave, if you what do you have to, I'm curious your thoughts.
I think that there's a lot of the explainability techniques that may not work just sort of computationally or space storage wise for large language models or other large foundational models in general. So I think there's going to be a lot of research around sort of computational efficiency of explainability for these large models. I think that, more specifically to your question, it's a really good question. I've been thinking about it a lot lately. I think the types of explainability that you'll see come about will look different also from what we have now. Because if we think about, these large language models, it's not just the overall predictive capacity they have, or, the generative stuff that they can do. It's also that they sort of represent the next phase, I think, of how we're going to be working with ML in general, which is you sort of come in and have a pre-trained model, sort of like what was pioneered with like the ResNets. And you're saying, great, okay, I'm going to take this. It generally works pretty good, but now let me adapt it to my use case. And so I think that we're going to see like just how these models took a lot of effort to train up front. Especially with regulations that are coming, we'll probably expect to see a lot of like accompanying documentation, model cards, that sort of stuff that explains the sort of pre-trained model itself. And companies will sort of do that great, like one shot, here's, you know, general like explainability for it. And then the next phase of it, where I think there will be a ton of research, is like, okay, now as I'm like fine tuning this model or doing prompt design, you know, working with prompts or stuff like that, there's going to be a ton of work there to understand, wait, did I really adapt this model in the way that I wanted it to be adapted? And, you know, how can I build up confidence around how it's behaving specifically now that's been narrowed back down to like, or, you know, customized to the task that I have in hand. There's probably also some interesting explainability around like chain of reasoning and the overhang capability of the model. Mike, what are your thoughts on this?
I mean, it's a good question. Yeah, it's a really good question. It sort of makes me think about, I think, Sophia, you asked me a while back about like explainability techniques for like generative models, you know, writ large. And so, you know, looking into that, I think it will be, I mean, again, like, I think there's a lot of room to do research in this area to better understand these things. And like, you know, even when you talk about large language, like language models in general, you know, I guess we touched on this like a tiny bit in the book, but we purposely didn't say too much, you know, getting into the details of like, but these papers exist. You can see some things written about like, you know, applying explainability to like attention mechanisms to try to extrapolate some, you know, some notion of an explanation for why, you know, it's making a certain prediction. But to be honest, like I think that's still, as far as I'm aware, and Dave, you can correct me if there's something that's come out since, but it seems like that's actually being called into question a bit. And it's really hard, like as a practitioner, to derive a lot of value from like, I don't know, trying to intuit from an attention matrix, like, you know, with multiple heads on a transformer, for example, it's going to be, you know, it's going to get really, really messy really quickly. And I think it will require just like a different approach. I mean, a lot of the techniques we discussed in the book and a lot of techniques I sort of think make sense intuitively are kind of like these, like, you know, like saliency methods, or like, you know, you're trying to understand like the features, like how is that affecting the input or the output of the model. And I just think it's going to take, I don't know what that will be. I mean, there is some research looking at like, you know, explainability combined with like the different types of generative models. And I think it will, I don't know what that looks like. If there's stuff out there, then I'd be, you know, curious to get my eyes on it, like and get into it some more. But and what I've looked around, I haven't seen much, but I think it will take like a different approach. And yeah, it's like a different way of looking at building models too, with this like foundational model approach. So yeah, it's a good question.
Awesome. Thank you so much. We're so grateful to have this opportunity to meet you guys and chat with you. I feel like I've learned a ton. It's so nice to just like talk and learn more. Like it's better than reading the book even. I hope you guys create a course someday on this topic, and then, you know, it will be very, very helpful.
Thanks again for having us on, Sophia. Yeah, thanks for organizing, well, one, that just like this reading book club in general, and thanks for like reading our book. I'm really glad you have promoted in that way. So thanks a lot. I really appreciate it.
Thank you.
Yeah, thank you very much for having us. It was great to talk.
Yeah.
Yeah, thank you. Hopefully I'll see you guys soon with your next book. Maybe fairness, right. Maybe something else. Look forward to whatever coming next, or even a course. We will go watch your course.
Amazing. And thanks everyone for joining. If you have any questions or anything comes up, feel free to reach out. I think Dave and I are pretty easy to get in touch with. So find us on LinkedIn or just connect in some way. But thanks everyone for joining the chat.
Awesome. Thank you. Have a good day. Bye.
Yeah, I'll see you later. Bye. See you.